All right, so we have a total of 23. Seems like it's all 22 plus me. Okay. All right. Let me just share my screen. One screen for now. So let me know if you can see my screen. And and today we're gonna just play with some. I'm gonna email you this file. So especially this Grasshopper script, I just made it. I'm gonna week 2. All right. Maybe I'm gonna rename it. So today's CE495 class or example 1. Okay, I'm gonna email this file to you. You see my the screen, right? So this is Grasshopper. You see the Grasshopper script. And what we're gonna do, I'm gonna show you some workflow about some dome structure. Before we move to the building, I think it's something that I want you to just find some interest and kind of geometry of any structure. So the Rhino 3D and Rhino is a design tool with Grasshopper, some script. I think this is really must. I recommend everyone, young age, learn something, learn some tool to improve your efficiency and productivity for future. I mean, this is one of the example, I think, of your for future careers. You're always willing to, I want you to just learn and develop your skill for productivities, uh, for the future. So, so let's see. And, week 2. Okay, so C 495. So Outlook. Okay. All right. So here, Grasshopper exam 2 file. All right. I just send it out. Just let me know when you are able to download it. So when you open the Grasshopper, Rhino and Grasshopper, basically, I'm gonna repeat. I'm gonna close that. So let me just start from scratch. So when you open the Rhino, you see Rhino, right? Maybe you can start it from scratch. I'm gonna using Rhino 8. So when Rhino 8 open it, okay, you might, okay. You may see this. This is escape. You can close it. You see this, the view may default unit might be fit, but it may be vary in your computer. But obviously, this is just the view of the Rhino. And here, what you see this, the green button, launch Grasshopper. All right, so this is kind of getting started with the Grasshopper, some template explanation, but so you see the Grasshopper since I've been playing with a couple of script. It showed my previous the script, but you could just go open that the Grasshopper script I sent you. So CE495 example one, right? So this is let's see, yeah. So this is the what you see. So let me know when you get here. So just for your information, Rhino, I think this is kind of design tool, but I think this is really most up-to-date technology and all design industry, including architect, use this. Even myself, structural engineer in practice every day, I'm most likely I'm using it because of the structural design form finding, right? The given some geometry structure from architect, I need to study and structural form and suggest the structural form to the architect. So if you don't know this 3D, this type of Rhinos tool, you can even provide your engineering service. We are a structural designer as well, designing structural form. So I want you to really understand and learn some this tool. There are a lot of tutorials now. I've been using ChatGPT and other YouTube tutorials. Sometimes I could not figure out the all these commands because there are quite amount of command. So usually I use some the ChatGPT or the YouTube. Someone actually typically commonly they uploaded this tutorial, but always is obviously sometimes is very and because they're not supposed to be then they're not necessary to be structural engineer. So I have to uh, kind of reframe it and get this script put together for my use. So have you got this? Anybody? Not yet?
Yes.
Got it? Can you share your screen just in case so that I can move next? So if you have a Rhino and Grasshopper open, the file I sent you, can you share your screen? Hold on a second. All right. Okay. Good. Right? Now we're gonna just practice. I know this one it depends on who everyone's. It could be awkward or something overwhelming, but this one is very you could think this is I mean similar to coding. I mean this is more visualized so that you could see the each command and component, right? It could be parameters, could be form, and all the command you just link by the line so that so you see the overall workflow. Sometimes it's multiple, but obviously what if I think I'm sure everyone actually learns some coding, either in MATLAB or Excel spreadsheet. They're all coding. Oh, chat. I got download. Okay, great, Amansa. Thank you. So now let's have fun. I mean, so I mean, when you see it, you see it. I'm sure everybody love it because this is the coolest tool because eventually you can build anything. The down the road, if we have some good example, if I find out using Rhino Grasshopper, we maybe kind of create either a 3D model, print 3D, or something wood origami structure. I wish I could always build some origami structure by using 3D no laser cutter. So we'll maybe try. Um, Maybe within 2 weeks or 3 weeks. So after maybe first session of a class, we maybe can visit the maker space and we can try to make something. So I want you to fully aware of this, though your kind of next careers. I think manufacturing skill is really helpful. All right. So it seems like I assume that you guys actually opened this. Let me close this. Too many. So first of all, when you open this, you see it because the grasshopper you maybe I'll give you just a few um introduction, right? This one when you click it, you see that each comment is has something. Oh, okay, okay, we have a new student come. Okay, hold a second. So just make sure everyone actually install the Rhino, and I just emailed the one script, CE495 example one. So I want you to open the Rhino and Grasshopper. Can I? Uh,
Professor, I just clicked my wheel and everything disappeared. How do I
oh,
get it back?
which wheel? You mean Rhino?
The
Grasshopper?
mouse wheel.
Mouse wheel. Oh, I have to see. Can you share your screen? Are you talking about mouse wheel? Oh, or you can close it, reopen it.
Okay, I'll try that.
All right, so let's say, I mean, sometimes always something happen, but a Rhino, okay, Grasshopper, right? When you open it and maybe close this here again, you could. This is like actually basic. You probably you already know this, but this is the one Grasshopper I sent you. When you open it, okay, let's see. Yeah, it opens yeah, it opens script. And this is actually dome structure, right? This is actually pre-made, I think, dome cutter. I downloaded from some communities, and some many cases. I wish to learn something more. So I've been researching and finding some good tutorial, and this is the one of the greatest because the reason why I'm working on some project, I think I show you some structure. I need to analyze it by using those kind of surface shell structure. So I need to build this geometry and for that geometry to the structural software. But problem is beginning, how can I get this geometry and convert it to the structure software? So it's just one step at a time. So we try to learn, take this example here. Okay. So everybody's okay. So how many? Let me okay, let me take a look. Do I miss anyone joining? All right. Okay. All right. Okay. All right. So we have a total 25. Okay. Oh, let me close this. All right. So everybody's here, right? So I'm gonna move on. First of all, this is the main DOM commands. What I think what you wanna see, try, if you're using the hold down your left button, right? Left button mouse, you could just select group by you could select all everything together. And I try to turn off because those are all the command is everything is really activated and showing every output. So I try to turn off this. So left the button click, hold down and select all this. And if you click the middle the the button scroller, right? You see that this kind of what is called the stop, and you could turn off this. You see that disable preview, so you can turn off this, right? Do you see that? It's the color, right? It's dark, which means it's inactivated. So let's say again, it's disabled. If you want to turn on, you could turn on this, right? So left click, middle wheel, turn up. So basically what I try to show you one by one. Let me just turn up this to turn off, right? If I turn off, I think turn off everything, right? So see, I'm gonna click this. Yeah, when you click this in the middle, you see that this is actually group already clustered commands, but they combine it, so they name it DOM cutter, but you don't have to learn differently. So what you could do is select, right click, turn on. So this DOM cutter has a couple of parameters, right? So point is reference point 00 here. Okay. But this one you could, interestingly, let's say, uh, we can right click. I mean, oh, maybe this is actually right click. You probably can see 000. Oh, no, no. So this is the point and the reference center point of this DOM. Under Grasshopper Rhino, you could maybe kind of click the node joint or single point. You can select this and move on to this point, right click, and you could just set this reference point, right? So this is kind of reference point. This is a point so that you could locate your DOM structure, right? So this is what you can see on the left side. We have a 5 input. The center, this is usually here reference point. So like showing the reference 00 point of this DOM. Maybe I could remove this to set one. Basically I'm gonna and deselect, select this, right click, set one point. So we can use 00 right here, right? If you hold down the right button, you can just append this, right? Why don't you just practice a little bit? I mean, this is pretty similar to other 3D software, Revit or other. I'm gonna select and delete this. So, so basically, this is kind of reference 00 point. This in the XYZ 3D. And as you can see, radius is radius. Since I'm using feet, this is radius of dome. See, let me just, all right. So you can move. This is a we call number slider. It's a parameter. You can set the beginning and end of numbers. All right. I'm gonna put this one in the radius 20. Let's say. Oh, this is slow. They are internally calculated. That's why. Yes. All right. All right. So radius and cutting curve. So this is interesting. This gentleman who actually created this has had a great um kind of add the all the interesting features. So what this means is, see that as you can see, this is solid dome, right? So we try to cut and trim this opening. And in order to do that, we can define some curve and a couple of curve. Somehow they project that curve on this dome and then trim it out. So what you could do if you're here, you could click this one and put it on the top view. It's a plan view, right? See that top view? If you click top, double click and you select the top view, and you can use this circle curve. You could click this and drag and drop. So if you want to move it, you can move around here by holding down this arrow, right? So this is, you could see if in case you cannot see this, this gumball should be on. You have to turn on and off this gumball, right? So I drew this circle here. I drew the circle here. Another click here and move and draw these three circles, right? So when you draw it, this one is on the top view on the plane. If you click this 3D, you can see this. The three curves are on the plane and on the elevation 0, right? Right? And then what we're gonna do, I'm gonna select Shift key and hold down. So I select three using Shift key. You select three curves, and then we're gonna assign these three curves in this curve command. But you move your cursor and right click, right? Right click, and you can throw these three curves to set multiple curve. And then what something happened, right? Interesting happened because this dome cutter is cut based upon this the curve. I think they projecting this curve on the surface and trim it out. You see that? How cool that is? But let me know anybody actually finished up to here. Anybody, can you share your screen if you or you want me to show one more time? One, share your screen if you finished up to there. Oh, good, good. No, yeah, if you're using the Zoom, yeah, you could use this share button in the middle bottom at the middle. You could click the share button. Good. So everybody actually build up to here, right? Just in case, because I want you to enjoy this. I mean, this is kind of unique because this last semester and this semester I introduced this because I want you to just find this is a very interesting the topic and fun. So now since this is actually it's basically virtual based upon Grasshopper script right here, right? If you click it, you see the color change, right? So this is virtual, it's not physical yet, this type of model, because this is formulated. And here, now, when you see, when you click this and then right click, you could see that bake. So we need to bake it. Either right click, select, and right click. Oh, wait a minute. Select, right click, either using bake here or middle button click, you could bake here, same thing, right? We need to bake it. Then what you see, there is some, this is the dome surface. Here is a mesh is generated because yeah, this is a mesh I'm currently, oh, actually I bake it. So if you select, if you already bake it, you can select and hold down any arrow, you can move and see. So this is still virtual, right? And this is the just model mesh I just created and move out from the original point positions. And this is kind of cool model geometry, right? Cool. You could just use right button, play around. Wow, right? Also, there is a nice rendering tool you can play practice. I mean, here, monochrome, good, host, artist. Yeah, you could just use anything. All right, I'll use the shaded. All right. So you guys actually finish up to here. You know, you learn bake, right? I'm gonna close this again. All right. So let's assume, or if you want to practice one more time, just do it. Go back to the plan. I think whatever you, anything that you're learning, so you need to practice a few times. Even myself, I always forget. So I'm gonna delete, uh, I have to inactivate it. Otherwise, it's a little slow. So let me see, turn off, close it. Mm, oh, okay, I'm gonna turn on. So, okay, so choose the circle. Okay, draw the circle this time. Maybe rectangle, circle, or polygon. Okay, this time I select Shift key and select 3 and dump to this curve. Click it, right click, set multiple curve. All right. So it's generate this truncated mesh, right? All right. So this time again, this is mesh. Click, right click, bake. If you just open the file, if you don't see this layer, maybe you need to, you can right here, you can right click and you can add a layer, new layer, right click, new layer, right? If you don't have a layer. So this is just something similar to AutoCAD, it's a layer. So again, if you click this, right click, you can bake it to any layer. Sometimes, I mean, when you bake it, this is one single mesh. So I'm gonna choose any layer. I bake it, select it, move, move away from the original point position. Okay. At least you have some sense of this because this is eventually a long learning procedure. I'm just using one example. The reason why, because once we develop some geometry, uh, So we need to sometimes decide to use the mesh style and number of mesh. Here, when you see this, it's kind of quadrilateral shape, right? I think this Rhino and Grasshopper made a good, did a great job, but sometimes we need a more defined mesh because of for analysis standpoint, or something like a more complex geometry and a sharp turn. We may end up to use the triangular mesh instead of rectangular mesh, right? So at this point, maybe I'm gonna use this, right? So everybody actually practice up to here a few times. I mean, practice. I mean, this is a good exercise, I think, and you can use different curve and different shape, but assign to the curve comment, and you can truncate and create the dome structure. Any geometry is fine, but I want you to familiar with this. So I want you to eventually learn this if you can, because down the road, the more complex geometry, if or geometry is very rationalized, method is mostly mathematic basis, you should be able to develop the geometry. Now, here, so once we create this, this is, I think, default I use the mesh. There is a two different type of definitions, mesh versus surface. For now, we're going to use a mesh. And one thing, let me see, can uh, actually, I still having a problem to build the triangular mesh. I mean, I'll show you here. There is something I need to figure out further, but you know what? First of all, let's do this. So here, right, you bake it, right? So this one bake. Let's try move to the SAP. So this one, right? So this is when you move it, when you select it, this is showing is a one open mesh. Now, instead of using Grasshopper based upon here, we're gonna go to do we have to do this? Or let's try here. Uh, a triangular. Maybe try. Okay, let's do one at a time. So type the mesh to nerve. You see that? Mesh to nerve, right? So when you select and type the mesh to nerve, it generates another surface. So if you select this and move away, you'll see this is one open poly surface. The previous one is one open mesh, but I generate two poly surface, right? So this is the poly surface we're gonna use to convert to the SAP. So again, once you bake it, you're gonna end up with open mesh, right? So here, type mesh to nerve, mesh to nerve, mesh to nerve in the Rhino, mesh to nerve. So it generate one there. The Rhino is gonna convert mesh to poly surface. So you see that one other another surface was created. So I'm gonna drag, hold down and drag and move. So this one is, hold on. Oh, this one is mesh. This one, yeah, this one is poly surface, right? So this is poly surface has internally, you see that there's a multiple planar surface is assembled together, merged together, or tied together. So this is the one we try to convert to the SAP. So if you're up to this point, if you select this, go to File and export, selected member. You can save this file, let's say, as the IGS form. So where is the IGS? So IGS, right? See that IGS? So I'm going to save as the EX1 example1 IGS file. So save import. Okay, let me click. So I export this file to IGS format. Okay. If you have the SAP open, let me just, I'm gonna delete it. If you install the SAP, let me just delete this. It's take a while. If you open the SAP, let me just reopen it just in case. So SAP 2000 version 25. If you open it, SAP, okay, you'll see it. Okay, you don't have to change anything. Go to File. You see the import. We're gonna import that IGS file we just created, right? So I just format, browse, and EX1 file, right? I create it and open it. If you open it, let's see. Okay, it brought just entities. We're gonna choose the surface entity and import. All right, it's imported. See? So we should be able to bring this mesh. Those are all segmented plane. Oh no, actually surface, right? So this is all an example of geometry creations. It's a one method and okay, and import the geometry. So in the SAP, you can turn on the nodes. Okay, this is shrinking the shell. You can spin this and see this boundary box. Control D, you can turn up this boundary box. So actually, up to here, we just create the geometry from Rhino using Rhino Grasshopper, export to the IGS file, and import it to SAP. Okay. All right. So I'm gonna just stop here. Let me know anybody actually proceed up to here. Anybody successfully finished this up to here? Let me know and show your screen and see. But everybody has a SAP 2000s. Anybody? one. Ninjura, Samantha, anyone?
I'm trying to open SAP right now, but it's just
Oh,
taking a while.
oh, okay.
Also, I have a question. When you make the curves, do they have to be on a single plane? Because I tried to make one in the front view, and
Uh-huh.
then I.
For now, use draw it. Yeah, curve draw on the top view, plan view,
Mm-hmm.
and the top view. Because I never try it on the elevation. I try to for now because this is more 3D. I don't know. This just use the top view instead of elevation view,
Okay.
side view. Yeah. While you're doing it, maybe show the region. Let me see. Is it on a? Okay, I think I have some tail project. Because we're gonna practice today a few model. Because I want you to at least have some sense of the geometry and modeling. Because down the road, this is really useful, and I want you to find some fun from this. Here, tail project. Hold on. So. Tail project. Oh, I delete all. Tail project. Did I delete? Oh, mm, yeah, I didn't have the example file. All right, so just in case while you're practicing it, all right, I'm gonna again here, I'm gonna show you again. So I want you to list the successfully finished conversion. I have to, uh, okay, and deactivate it, and okay, right click and show this again. This perspective is in 3D view on the top view, not front and right view, because I think this one I never tried from the. But if you draw this curve on front and right, probably let's try because I don't know how this one is projected on the surface. Probably nothing's happening here. Huh?
Yeah,
Oh,
that's what I tried. But then it just deletes it when you set the curve.
yeah. So it doesn't work. I think this is actually setting up. It doesn't work because this is curved on the plane on an XY plane on the top, right? So yeah, this one was just set it up this way. But this is a curve. I'll use a more gentle curve, right? So select all these three curve with the shift key again. In the curve, command right click, assign the set multiple curve. Now this truncate. Yeah, this is pretty good. So again, click perspective. So this is a 3D structure, right? Again, if you practice a few times, if you want to practice, here mesh, right click, bake it, select any layer, and okay, select and move this. So you see that the model, but I want you to take a look at it. This is actually mesh, open mesh, but the SAP 2000 doesn't register or mesh. we need to use a polysurface. So that's why we need to save this file or convert this file to surface. So by typing mesh to nerve, right? Mesh to nerve. When you do that, it's generate another, let's say, yeah. So open polysurface. So this is the one, it's a multiple, you see that surface? So I think this is some difference mesh. This is more curved looking, right? This is more smooth. But this polysurface is segmented. I think we can refine more so to make more curve looking. But for this study, engineering's perspective, we can just use a coarse mesh, still good representation, approximation model. So we can use this polysurface, right? So polysurface, basically select and go to file and export to IGS file and import it to the SAP. So why don't you actually try at least one time to SAP when you finish it and let me know. So I'm gonna do it because what I'm gonna do it show you one more thing is instead of using this quadrilateral mesh, we're gonna use a triangular mesh again. So here I'm gonna give you another example. Go to export and I'm gonna just override it, X1, override it. So IGS EX1 IGS file. Oh, so override it and go to SAP, go to file and import, right? Import IGES file and browse EX1, open. So here you choose a surface entity. Double click, oh, click. Okay. In 3D, yes. So this is kind of, I want you to aware of this is the workflow from design tool to structural SEM model. I mean, ETAPS is slightly different because ETAPS has the same analytical engines, but was built for the building type of structure, so their environment is slightly different. So we need to define the elevation for the building. We need to set the each floor to floor height so that some geometry standpoint, we need to add a few, and we're gonna use a slightly different, the procedure in order to export the geometry and import it to the SAP, the geometry. But up to here, if you are successful up to SAP, let me know. So what we're gonna do is I'm gonna show you the another triangular mesh. So rectangular mesh like this, we call rectangular, right? It's quadrilateral elements. And we're gonna create another triangular mesh. So we're gonna import two model. And once we import two model, we're gonna start signing some loading and set the boundary condition. We can analyze this structure based upon just on self-weight of the structure, self-weight of the structure. So if you actually finish it, let me know. Show your screen. Meanwhile, let me see. think we may try the truss or some other simple exercise. Okay. Anybody finished? Show your Rhino file. You could share your screen, Rhino and the SAP. Okay, someone said. Okay. All right. Okay, Rhino Grasshopper, great. SAP. Oh, behind the. Okay. Good. All right. It's fun, right? Right. It's same, very same procedure. I mean, overall same procedures now. What since this, let's say, yeah, maybe this one. Oh, this is poly surface. Okay. So I just keep this poly surface. When you click it, poly surface right there, and I'm gonna recreate the another model by using triangular mesh. So when you generate this, see when you click this, you see that green color structure. This is the geometry I'm working on. And then on the right, this is mesh. I'm gonna activate it, right click, right? So this is the
Professor, we can't
yeah,
see.
yeah.
We can't see your screen.
Oh, sorry. You Where did it go? Okay. All right. Go back to Rhino. I didn't do much. So basically, this is the one we just created. So if you have, if you create the mesh, the structure, right? And then copy over mesh to, let me just show you one more time, just in case. If you click this, right click, bake it to the layer, click this, and you can move away. When you bake it, this is here, is the mesh. But if you, in order to import to the SAP, again, you have to type mesh to nerve. See that mesh to nerve, right? If you click it, there will be another, the model is created. When you select it, you see the open poly surface. So you're gonna use all the poly surface model. This is the one I created before. So now same way, but I want to use the triangular mesh. So whatever, just I create this mesh. This is mesh. Here is the triangular mesh commands. When you right click, you can bake it again. Different layer, right? I create it. Same things. Click it, move away. And see, this is open mesh, but it has the triangular mesh, right? Right. So using this triangular mesh by the right click, bake. Once you bake it, move this one away to here. Since this is mesh, same thing. You're gonna do the mesh to nerve. So, oh, you let it create it. I'm gonna move this one to over there. So, oh, not this one. This one is, yeah, this is open surface. So see, this is open poly surface, open poly surface. So I want you to create this. So basically, when you create it, same thing, you can select and export it. If you click, same thing by using triangular mesh, right? Bake it. Once you bake, you move away and select and mesh. You can type mesh to nerve so that create the poly surface. So this two is same identical geometry, but I'm using one is quadrilateral mesh. The other one I'm using triangular mesh. So once you're done here, same way, you could export to select it. So you can, yeah. Oh, example one, the quads and triangle. So this is the IGS file I'm gonna export. Let's see. Say OK. And go to SAP. IP, it doesn't matter. I still can automatically open the new file. So IGS, save, no. Go to browse, go to EX1. No. The quad and triangle, right? IGS file. Open it and select this surface entity and open it. All right. So see the geometry is done. So let me know when you're done. I think once everybody actually import those geometry in the SAP, we're gonna now from now on use a SAP for next step.
Professor, can you repeat how you go from the triangle mesh
Oh, okay.
to the
Okay.
squares?
So here, same thing. When you click this is dome cutter. You see this, right? Same. So you're okay with here, right?
Yes.
And yeah, and here is next step because this is general using quad mesh, so you have to use this triangular mesh command here, right click and bake it. Choose any layer. When you choose the layer, basically you bake this geometry. When you click this, you see that you have a physical digital mesh geometry here, one open mesh, right? So you're using this triangular command. And then again, repeat, we're gonna type mesh tuner because we need to convert to the poly surface. So when you type the mesh tuner, it's highlighted. You can move this one away. Let's say this one is, oh, this is mesh. This is poly surface, right? So I'm gonna delete the mesh model and using poly surface model and just put the side by side. So both are poly surface model, poly surface. See, poly surface and poly surface, right? After that, if those are poly surface model, again, select it, go to file and export to IGS file. IGS. If you here's IGS, and name it. Again, I use quad and triangular. You can override it or you can rename it. So generate IGS file. Well, you have to say OK. And then next is you could go to SAP. I already imported. Now, if you want to go re-import it. So go to file, import, IGS file. I'm not going to save it. Browse and select this IGS file you just created. So what you need to choose here, the first one, surface entity, rational B spline, surface entity. So when you, okay, so I'm gonna stop here. So if everyone should be able to finish up to here, that's great. I mean, those are all the exercise between geometry creation, then converting the shell using polysurface, mesh to polysurface. There are many different ways to create the geometry and convert, but IGS file is pretty kind of convenient for me. So far, using IGS file might be line. You could use a DXF file as well, but I think IGS file is most convenient. You can export and import surface and line as well. So this is an example for surface, right? But we're gonna maybe try the line if we build some triangle. I think last week, the first class, we play with the line so that we maybe practice one more time. So I want you to at least feel this. It's cool. Basically, it's cool. If you really wants to build something structural, I mean structural model or physical 3D or laser cutting model, I want you to have some skill like with the design tool, and you can have build your great hobby or hobby for some making something. If you're done, show me where you are so that I could move to next step in the SAP. All right, one. All right, SAP. Okay. The something is out there, you could delete it. It's just we're gonna play with yeah, surface model in the SAP. I saw some line works outside. So you can select in the SAP and delete it. Any other? Yeah, show your screen. Anybody's successfully finished. So everybody actually installed SAP and SAP is running. Okay. You create a couple of them. Nice. SAP. Oh, there is something missing. Hold on a second. Can you show me again? Let me see. The triangular element, the line work, yeah, here edge member is missing. Yep, there is. Can you show me your Rhino Grasshopper?
Yeah, sure.
You said something is missing here, line there. So basically, okay. Yeah, can you here? Can you let me see. Yeah, click it, right click, bake, and choose any layer. Okay. And okay, move to the right. Okay. Select and type the mesh to nerve. So this is the okay, poly surface. Yes. Click this and export it one more time. Oh, one thing maybe okay. You're using yep. Okay. Oh, you're using millimeter. You could change to Yeah. If you want, you could go to file and reopen it as a fit because a millimeter is too small. So go to file, click this, new. No, yeah, you
Oh,
don't have to save it. Don't save it because you can create anytime easily. Yeah, no. Oh, okay. Here, fits. Yeah, fit. Choose open. So now is everything is in fit. Go to Rhino again, recreate it. Yeah, open the Rhino. Yeah. You could, if you want, you redraw the curve. And again, the learning new tools, minimum, I think you guys have to do it 3 times. Then you get there. I mean, this is just repetitions. So, yep, great. So if you want to create two, yeah, bake it, then move away, push it away. No, I don't think image, right click, bake, yep. Now sometimes may have doesn't work back. May have to you may have to restart. Sometimes uh why it doesn't do bake? No, okay. Maybe yeah. Or create this mesh here, or maybe bake here. Oh yeah. The same thing. Yeah, this is oh yeah, got that. Okay. And maybe yeah, do it triangular too. Okay. Click that away. And then select both and mesh to nerve. Okay, and export it. Fully surface, yeah, fully surface model. Well, fit. Yep. Import again. Import. Yep. Oh, wait a minute. Where the triangular? Did we export? Oh, where is the triangle? Wait a minute. This is not triangle. Hold on a second. Triangle mesh. Yeah. Can you move to the left? I think this is, yeah, wide. Left. Go to left. Left. This is quad, mesh. So this one should work, triangle. Can you right click and activate it? This one, right click. Oh, no, middle button. Here, yeah, this one, view, preview. And, okay, can you hover on the mesh here, right click bake? Can you zoom in? Oh, why? Maybe. mm, Maybe bake. Choose a different layer. Choose a different layer. I keep showing triangular. No, I think she's straightforward. Why you're can you maybe close the grasshopper and redo it? Or maybe file. Yeah, go to file and close yeah, file. Yeah, maybe you can close the Rhino and reopen it. Then maybe. Close the Rhino and reopen it. Yep. No, you don't have to okay, Rhino. Yep. Yeah, use fit. So open the new. Okay. Yeah, go to Grasshopper. Yep. Go to open that file. Okay. Draw the curve and on the top view. Yep. So, some setting. Okay, right click and bake. Okay. And do triangular too. Nice. Why your triangle doesn't work? Hold on a second. I see it. Can you zoom in here? I think I see the triangle. Yes, over there. But when you bake it, doesn't bake this one is something key. So when you hover this mesh, click this, and on the top of mesh, right click, and bake, and using different layer 5. Okay, now, yes, there. I don't know why. Okay, all right. Yeah, export that too. Nerve, mesh to nerves. You see, new tools. If you practice three, four, 5 times, you can run very fast, right? It's always the skill you need to repeat. IGS file. IGS. Yep. Yep. Oh, okay. There is a one thing is triangular. All right. So triangular, what setting we need to do? Go back to the Rhino. So triangular mesh, we need to just go to Rhino. Yeah. So maybe select all this again. This is poly surface. Uh, is a mesh. Okay. Can you bring this mesh? Okay, hold on. Can you create the mesh? So what those are mesh? So which one is mesh? This is both mesh.
These two are mesh.
Okay. Oh, mesh selected. Type the nerve to mesh to nerve. I think we need to click something there. Mesh to nerve. Oh yeah, actually move very fast. Mesh to nerve. Can you type this one more time? Let me see. Here. Yeah. Mesh to nerve, but we need to say no one thing there. Type enter. Click it. Ah yeah, it moved. So don't select it, mesh to nerve. Don't select and just type mesh to nerve. Yep. Click it. Oh, here, click this one. No. Yeah, it changed to no. Okay, now. Okay, now select this. Is escape and select to model and type the mesh to nerve. Yep, enter. So I think there is something truncated. Yeah, so then you can export this to poly surface. Wait a minute. This okay, and then move. Yeah, delete all the rest of them. Keep the final one and move this one poly surface out. It's only we need to somehow trim. So this is okay. Yeah. Okay. When you zoom in, you see that. Can you zoom in? So you see that the Rhino is showing some line like this. Means this is poly surface, but it's I think a trimmed poly surface. So this one should be okay now. Export it. I still looking for Rhino command for this last step, but I could not find out. So I'm trying to figure it out. So be imported. So yeah, the triangular mesh should be okay. All right. Looks good, right? See everyone, actually, you have to practice a couple of times. I mean, this is try and error and some miscellaneous, even the setting changes, really saving a lot of time. Basically, I was actually play more the Grasshopper more, but the Rhino is main body. Grasshopper is kind of plug in, so I had a kind of the struggling time to figure out how to this works, but eventually I could find out one simple setting can change my life. So up to here, everybody okay, right? So if you create up to here, do so. We're gonna just move into the SAP. So I'm gonna show you the SAP. So here is my model, right? Let me hold on. Let me share. So I assume everybody actually got some geometry like this. How can I close that? Okay, right? So this is blocking it. So now SAP. This is SAP, right? SAP model. Assume that you create the geometry, but creating a geometry like this in SAP is impossible. I mean, you need to draw it in 3D software, either CAD or Rhino Grasshopper or SketchUp. Somehow you need to find out, learn some. Since we are in the architectural and the building industry, I keep mentioning it. Rhino is the very common, and I'm gonna give you the homework maybe next 2 weeks. You're gonna just visit the architectural studio and have some interview or had a talk with architectural friends, what they doing and what kind of tool they use, and they can show maybe to you some previous their project, right? So I want to tie all of you with the architectural studio students because this is must. We are the basically same body. We are doing even though structural engineering, but we are usually speak same language. I want you to learn and also have some uh the network with architectural students. So up to here, assume we just import the geometry. This is if you click this, right, you can see that there's triangular. Now we're gonna learn a little bit basics of the SAP and ETAPS. They are pretty much similar. So you see the menu at the top, main menu and short key on the left. And then what you can see, first of all, click this, am I still recording it? Let me double check. Yeah, I'm recording it. So here, a checkbox, you could turn on and off. So where is the joint and frame? Frame is line. Joint is obviously joint. We can turn on the joints and yes, turn on the joint here, right? This is all the joint should be one, and they're showing, hold on. Yeah, 1 point, the joint, and you can turn on and off. Here is a clear button. Okay, where is my button? Yeah, clear button. And you could shade it so the shell can fill this surface, fill object. So you could see that the surface, poly surface we imported. So now one thing that I want you to, this is some surface model geometry we imported, but sometimes if this is a huge structure, could be the two kind of 3D space structure. Typically 3D space structure, we use 3D truss, right? Three-dimensional space truss system, but that is another level of geometry exercise. But for now, today's is I'm just showing you playing with the surface and import. So this is instead of a 3D space truss, this is shell structure, which we have only one layer of the surface, right? It's a one layer, right? The both are representing same structure, but just structural standpoint, analysis standpoint. Sometimes we're using rectangular quads elements versus triangular elements. It depends on geometry because sometimes their behavior is a little off. So always good to know and to matter. All right. So I'm gonna just gonna now practice the SAP briefly. I think it's fun. So we're gonna simulate and see the building structure. So first of all, same thing. It's only geometry. This is surface. So we need to input material properties and member properties and boundary condition and the loading condition, right? They're all same. The input we need to define so that SAP structural analysis software can analyze it and their static behavior. So first of all, so on the top menu, I think others of edit and view is pretty much view, but here define is we're gonna go to define and take a look at the material menu. So on default, we have a concrete 4000 psi concrete and rebar A615, and there is a steel, right? So we'll maybe let's try to use some material. Assume this is concrete structure, shell structure. If you open this material properties, you'll see some material related properties, right? Weight or per volume. And if you want to use a pound per foot, oh, somehow I use kilonewton millimeter. You know what? Let me change to unit pound per foot and reopen it, re-import it, import it, import it. I think I use a fit, so it should be imperial units. Okay, so now this is imperial unit. So go back to define material, right? Concrete. We assume this is concrete shell structure. Hello, anybody needs help? All right, I'm gonna just walk through and you guys actually first of all watch it. If you're in the SAP model, successfully you import it, so you can follow along. So here I'm just give you the general introduction of SAP model. Since we have a geometry, right? It's only geometry. We need to define the material properties and section property and boundary condition and load condition. Load. So here I'm just show you the material defaults, the concrete structure, concrete material, so unit weight, and Young modulus. Young modulus. Typically I use cubic inches, so 4,000 psi concrete. Young modulus is 3,600 ksi, right? Kip per inch square. And Poisson ratio and coefficient, but most likely Young modulus is the played a big role here. So this is material property we're gonna use as a concrete structure. And again, go to define. When you import it, I think the SAP is automatically choose the default section properties. So how can we know, how do we know it? So if you select, click and right click, you see that the object model pop-up menus showing the assignment. There is a section name is a section sec one. This is default, so we need to change this section properties. So it's automatically throw into that one section properties as a default. So we're gonna go to here section properties, and since this is area sections, click this. There is default, right? A sec or non-member is none actually. So ASEC1 is type of a shell structure or shell element. I'm gonna explain that later. When you open it, see there are type of element we call shell and plate and membrane. We're gonna keep it as the shell. And here thickness is 1 foot is too much. So I assume six inches, maybe 6 inches. So 0.5. Right? Membrane and bending is more numerical terminologies, but I will choose the material concrete for 1,000 psi concrete, right? So thickness is 0.5 feet, which is 6 inches. So it's name convention, maybe I would say it's a 6 inch slab, right? I keep the shell structure. So I just redefine our section property, which is this is concrete shell structure, which is a slab, concrete slab, right? We call shell, but this is 6 inch concrete slab. So since default, I changed the name, select right click, you'll see the section property, section name is automatically changed because the default name, I changed it, rename it. So everyone should be 6-inch slab, right? Okay, now, so section properties is associated with the material. Again, go to section property, area section. If you go open it, yeah, you always section properties are associated with the material properties. We're using 4,000 PSI concrete. All right, that's simple. We are just define some the section material property and section properties. Now here we're gonna assign the boundary conditions, right? You know that all the boundary condition, which could be spin or fix or roller. And we're gonna somehow assign the boundary condition at the bottom of building structure. Since we have many nodes, I think typically I prefer to use 3D here, 3D view here, right? And choose XZ plane, aperture 0 or YZ, doesn't matter, but I'm gonna project every elements on XZ plane with the aperture 0. So I should be able to select all the nodes at the using window selection. So you see either this way, depends on your geometry, YZ, aperture 0. You see everything is right there. So you're gonna click using window, hold down your left button key, right? And drag and drop, you select all the bottom node, right? Right? Basically, you select all the nodes, to assign the boundary condition. So this is all the nodes at the bottom, most bottom elevation, which is, I think this case is 0, 0 in vertical coordinate. And we're gonna go click the assign and join and restraint. This is boundary conditions. Join restraint, right? We're gonna assign as a pin here. So XYZ is translation XYZ. When you say, I think you guys learned the pin connection, is a pin boundary condition is this pin. Since we are working in the 3D, so you have to pin it in XYZ plane, right? So either you see this is Shoki. So it's a pin XYZ. We don't have any rotational resistance, which is if you have all this is a fixed conditions, well, we are using pin condition, right? So if you assign it, you see that the symbol, the triangular symbol, this means a pin connection, right? So we assign basically section property with associated material and assign the boundary condition. Building is standing up. Every building is same thing is cantilever, vertical cantilever. So it should be fixed or pin at the base and they're rising up, right? Okay, if you want to play with this checkbox, turn on the fill object. Okay, you can turn on if you want to turn off the nodes here invisible. You can yeah play around this now. So basically we are ready now. Now next step is defining the loading. So we're gonna define the load. So in the define menu, here is a load patterns, right? So when you click this, the default, we have dead load and dead load type and self-weight multiplier is 1. So this means there is a one load case, load pattern, dead load. And here there are different type of design load, right? We're gonna keep it that. So what we are interested is in our self-weight of structure, right? Self-weight of structure, we don't want to calculate by manually. ETAPS or SAP, they know that since we define the geometry and slab thickness, right? We assign 6 inches slab. right? So SAP can calculate internally for their the self-rate. So this is kind of the convention that SAP can calculate their self-rate. We type the one here. If you want to later on assign the other live load, let's say we have another live load or snow load, you can generate here. You can add another load type snow. But you should actually, this self-rate multiplier should be 0. So only self-rate, we treat it as dead load and put this 1. Rest of all the load cases, load pattern, we should keep this 0, right? So we're gonna run the analysis for only self-rate. So say okay. So this model is ready to run. So here or here, analysis and set analysis option. Now let's take a look at analysis because this is okay for analysis, this run analysis. But before you go, maybe let's take a look at analyze set analysis option, right? So looking at this, obviously, this is 3D structure. We are following XYZ Cartesian coordinate system. So far, probably you practice 2D, trust 2D. So most likely XZ plane or YZ plane, you analyze truss or beam, something like that. But in real 3D structure is basically 3D element. So we need to use a 3D XYZ coordinate system. So here we commonly use degree of freedom. X movement translation, they call translation. X, UX means translation. Y is translation, Y direction. Translation, Z direction is a movement in X, Y, Z direction. Rotation about X, rotation about Y, rotation about Z. So each single node has a 6 degree of freedom, right? One translation and rotation for at the X or Y, Z. So in 3D, we always have a 6 degree of freedom. So here, some setting, but since this is 3D analysis, 3D model, we're going to keep it as default 3D. And if you can just here run analysis here, right? This is run analysis, so here is a shortcut. So let's run, right? And when you click it, it's asking which load case do I want to run it. Okay, I didn't assign any loading, so I'm gonna run this model. It may be asking the folder. Okay, W2, this week 2 example, this is example 1, please name it, and then I'm running the model. All right. So when the SAP finished the analysis, right, it showed the deformed shape, the displacement in the first hour deadlock cases, right? So, okay, so this is kind of exaggerated building deformation shape under the self-fade. Here, if you want, click this start animations. So you could see always cross-check your models. Everything is connected and properly showing that your expected building behavior is based upon self-fade. Seems like makes sense, right? Is building structure is deformed like this, right? Vertically. So now, once analysis is done, you could check the stress, and you could see, you should be able to see the deformation shape, right? So this is mostly a graphical representation under the self-fade. We didn't assign any additional loading. We just use self-fade deflection. So now all after analysis, there is a display menu here, right? I mean, show deform shape, or we're gonna check the stress, something like that. So so here is also a shortcut here for deformation shape. So if you want, maybe use display, same thing here, show deform shape. Now we keep the deload cases and option. So let's show wire shadow, and maybe here contour option we can using some color legend to see that overall intensity of displacement and vertical direction. Show continuous contour. Okay. So I keep this. Let's say okay. And you see that so visually, graphically show deformation shape over superimpose the original shape, right? So, I mean, you could turn off this wire shadow. Yeah. So this is deform configuration. It's actually color coded for each intensity of displacement. So you see that this is legend. Uh, Typically, displacements, we are using inches because deformation, you don't want to just see that foot and level, right? So when I'm looking at the displacement, I usually use inches. Also in metrics, I usually use millimeter, right? Not meter, right? So here, you can see it when you move your cursor, you see that uh, some numbers. Let me just move this. Right here, the 0.003 inches. Oh, no. But U3 is vertical displacement, 0.0188. Here, 0.0205, right? Minus means vertical. So XYZ is you could see that our typical Cartesian coordinate system XYZ, where it is. Oh, here. See, this is XYZ, right? X, Y, Z, Z is vertical. Typically, we're using this left-hand rule, maybe X, Y, Z. Vertical is Z. And this model I create, let's say, yeah, okay. I create X is this direction, Y this direction, vertical is this, vertical is this, Z direction, right? So again, go to the formation, click. Maybe you can just also you can visually magnify, so visually can see this automatic versus user scaling. Maybe so sometimes visually in order to choose, right, this is amplifications scale so that visually you could see clearly and confirm the building behavior modeling the input. You could just cross check. So again, this is self-fade deflection simulations. The color indicates their intensity of displacement. Oh, you see that happening? So SAP is always, even 27 years I've been using it. It's always during this animation, it crash. So save current changes. Okay. I have to maybe. No, okay, it's fine. Now, typically, I need it shut down automatically. All right. And memory issue. So, okay, so I want you to, so take a look at the displacement, the form shape, right? So this is a scale. You could just play around and you can click this and pay attention. I want you to, because you're all the engineer, again, you are the all engineer. I want you to pay attention and observe. So what the features doing what, right? So this observation skill is basic in a scientist engineer's skill. So observe what's happening here. So this is what we see, the deformation shape for both model. Same identical model, material, the slab thickness, and material sections and boundary condition is the same, except the mesh type is different, right? So sometimes we have to make a judgment which mesh type is, I think is more makes sense. One thing that you maybe see is because I think SAP, we are using a little bit coarse mesh, somehow continuity wise a little bit off, but I think overall behavior is showing pretty good for this example, right? So first thing is that you always check the deformation shape and see whether this makes sense or not, right? Because the sulfate is always pointing down into the gravity direction. You should be able to have sense whether this structure behavior makes sense or not due to their sulfate. Now, next one is we're gonna check the stress, right? Because we are using the shell element, surface elements, it doesn't give us the forces. Instead, we're checking the stress. So I'm sure you already know mechanics. You take the mechanics class, whatever, just force divided by area, right? Force divided area, you can get the stress, compression, the tension, stress, and shear stress, something like that. So in the here, show stress shell. So same deadlock cases, I'm gonna choose a shell stress. So because of this shell structure, the visual phases, this S11 and S22, we're gonna talk about it. This is a local axis, is directionality. So if you choose it, and it show the stress on this and the surface. So basically, I can turn on the deformation surface, and then also maybe this is a boundary minimum and maximum ranges, and you could you can give something, and okay, so I mean stress is pretty small. That's why I need to find out what is the maximum and minimum. So let's see. Maybe for now using automatic, so at least you see in just stress mapping contour, right? So when you see it, see that there is something compression at the top, bottom might be tension, but you could see the stress. Okay, I'm looking at S11. Now, what is S11 is means here? I'm gonna show you local axis of the shell. We're gonna maybe talk about it briefly later. Let's see that when you turn on the shell and show 3D, the local axis, typically red is local axis 1, this green is local axis 2, cyan is blue is vertical, local axis 3, right? So that is a sign convention. Now, some 3D analysis and meshing is really it. SAP is throughout this surface local axis for our future use. We need to aligning this local axis for our rebar reinforcements design. All right. So up to here, I'm gonna just hold on. So I'm gonna stop here. Anyone actually were able to assign this app and show your screen? Any progress? Can you share your screen? No, no. Anybody working on it now, Seth? Any volunteer? Show your screen. It's okay. I want to
Mhm.
see.
Professor, can I just ask, why is it a pin connection and not fixed?
Yeah, this is kind of the arch structure, right? It's a 3D arch. So arch typically work as that the forces or uniform loading on the top is go through the initial form. So at when it hit the bottom, I think it's mostly transfer the forces in X and Y, V. Um, Basically, we can fix it too. It's only just the arch is since arch is more primary forces is and then the the translation XYZ component, not moment. So typically typically arch we play with mainly this thrust. But since concrete structure, sometimes we fix it and design it as well. But in if we fix it, then we need to deal with something large moments induced stress. So obviously, it's typically when you see any arch structure, even steel, I think you see engineer mostly use a pin connections. So that's a good kind of question. Sometimes because of this one we use as a concrete, so we should be able to fix it. But if you fix it, you're gonna have a pretty negative and moment will develop since we are using 6 inch slab, right? In this model, it's quite thin and it's hard to add a two layer of rebars in the 6 inches. So just I assume the pin it for this exercise. And 6 inches is pretty thin at this point. In the practical words, if this is real structure, I'll more thicken that thickness at the base and or parameters edge along the parameters where that more stress will occur. Most likely I end up with thicker thickness at the base and around the edge.
Okay, thank you.
Yeah, I mean, this is a lot of good exercise. I mean, if you practice in building structure design, or there are tons of tutorial in Word, and I'll send you a couple of example and website. And if you're really very interested in to learning this, yes, there are tons of tutorial. I want you to just kind of look at it. No matter what, since you are in the civil engineering, right? I hope you guys actually find many reasons to enjoy this. All right, can you show your progress, Sap? So late 12 o'clock. So after, if you guys are currently working on it, let me know. I'm gonna, let's see if this video is pretty gonna be big, but I'll post it. And you guys actually follow along at least the practice because that is the only case that you can learn it. And just follow along. Um, and maybe we're gonna have a just maybe bio break, 10-minute break. And briefly, I'll show you just design workflow in the design industry. And we can wrap up maybe 12:30 or 12:45. So nothing, because unfortunately today is only heavy snow. We don't have the in-person class, but you could just practice this SAP at least, because the reason why, because I have a couple of young engineers, I still like train them because they didn't have any opportunities to learn this Rhino Grasshopper. I mean, it's not only I'm talking about Rhino Grasshopper, it's a geometry. How you gonna handle the geometry, right? In order to design structure, come up with a structural form, you should be able to, everybody should be able to create 3D geometry based upon given architectural software or some tool. But if you don't know, if you don't have any skill, how are we going to draw it? Is going to really time consuming and we can't even provide any service. So dealing with the geometry is the must skill. Then the next step is how to rationalize and come up with a more economical geometry shape we can come up with and can analyze and design and develop the detail drawing. So more and more you see more complex buildings shape. So no matter what, if you're in the building industry side, this is must skill. I recommend. I want you to have double edge. When you go out, you're most likely you're moved to the you're going out to the markets industry. I think you need to really have multi edge talent skill set. Anybody actually finish this app successfully? Show your screen and we can take a break. If not, I'm gonna post a video and you can follow along. I think, and everyone actually practice really, and you'll be surprised. It's later. It's not easy to find some tutorial like this. People really struggle and it's hard to catch up. So I want you to at least practice and bring your exercise SM model and Rhino model the next class. And meanwhile, I will talk with the one of the architectural studio. So maybe in next couple of weeks, you guys actually can arrange them visit, or we can just visit their class. But likely, yeah, one studio I talked with, they gonna working on some project in the Hudson Yard. But their class is Monday or Thursday afternoon, so we need to arrange this. So I'll let you know. So somehow we need to find time to visit their studio. Okay. Are we gonna take a break? Okay, so let's take a break. And if you wanna work on some further SAP, spend some time. And let's come back to 12:15 and briefly, talk about the project, the organization, and the workflow. And if you have any question, look at the posting video and bring later on everything's next week. So I want to see how you guys actually uh, complete this. Okay. Okay, we're gonna have a 10-minute break, 12:15. All right, everyone. Anybody actually successfully finished SAP analysis? All right, let's get started. Are you there?
Yes.
Yeah.
All right. So we're finished the ETAPS? No, SAP. All right. If you have any problem, let me know. I think it's because this is a procedure is pretty similar in ETAPS as well. And we're gonna just walk through the briefly that today's kind of session design, yeah, process. Let me see. Okay, hold on. All right, so we just start with this something the design workflow as structure engineer in practice. We opened obviously play with the geometry. So I hope you guys actually have some sense and enjoy learning new tool, and you could do something rendering nice graphic whenever you create this. Just practice a few times. And the Grasshopper script is something I think is more to go, and but this is kind of the starting point. All right. So okay, so today just I'm gonna just briefly talk about it, walk through, because this is something that I want you to aware of it when you join industry. Depends on which industry are you gonna land. And but this is something more building industry, the design workflow. I want you to aware of who is the main stakeholder, design team, players, and what kind of design procedures usually can we follow. So I want you to at least aware of this, right? So today is just briefly, we're going to talk about the design team organizations and building design procedures and the project workflow and design phase, and each phase, what kind of scope and what usually design team generate uh, along the design phase. I will show you briefly that as a structure engineer and what is the structurally deliverables. Basically, what is the documentation we provide to the owner. So I think as you said, I mean, building industry, we are, I mean, in the civilization, civil engineering is embraced pretty broadly. And I mean, environment now civil environments, but just when we say civil engineering, the previous the decades, we usually civil is represented by the structural engineering, but now things change and civil engineering is embraced the environmental as well. So also transportation as well and hydraulic. So I mean, still civilization embrace mainly the structural engineering, geotech engineering, hydrology, transportation, environmental, right? And now NJIT has some construction management programs, but they are all connected, strongly, closely connected. But focusing on the building sides, obviously there are three main musketeers led by architect. Architect is usually hired by owner client or developer typically and early on, so that they usually studying the zoning requirement and program requirements, something like that. They developing early phase design program. So architect usually get involved earlier. As the program is settling down, they usually uh, um, need structural and MAP support. So many cases, and as a structure engineer, we got involved in schematic design phases, and except some huge project, right, starting from urban designing and master planning phase project. Uh, Typically, if single building design project, as a structural engineer, we get involved during the schematic design. We're gonna talk about it later. So I want you to aware of it. Architect is usually played a big role, project manager and project designer, and they closely work with the contract owners, developers, owner clients, and usually owner uh, usually rely on the architect to bring the consultant during the design phase so that they can develop all the design package together. So here is architect and structural engineer MEP. We are the main three, the parties developing and leading the building documentation. And mechanical engineering wise, I think is yes, consists of the three trade: mechanical, electrical, plumbing, right? So typically mechanical party is the play a big role. So mechanical engineers usually representing electrical, plumbing, sometimes obviously all three parties is in the same one company. So MEP company is usually dealing with the three trade. But structural engineer, we typically standing alone. Some company maybe have geotechnical engineering services they provide, but typically structural engineering is standing alone. My company so we are providing only structural engineering services. So here is showed the kind of typical architectural design phases. Since from the architectural side, they get involved early, and contract owner and clients, they always kind of study the each joining and obviously pre-design phase and program requirement, height, building height, and total area of the requirements they study, and based upon the yeah that kind of program, they kind of lead this and initial the schematic design. So we get involved with schematic design typically, and obviously it depends on the size of building and complexity. The schematic design development can be combined as one, so that when the program and overall the program is fixed, then we can move on to construction documentations. So typically we as a structural engineer develop structural drawing and sometimes specifications and some other design narrative, but typically structural drawing is primary drawing deliverables and specification we usually deliver to the client. After all construction documentation is complete, obviously client put together some bidding package, and that they invite the bidders for their bidding procedures. So graphically, you could see something, right? In concept programming stage, what kind of obviously it's something that clients want to make sure that each lot is kind of allowed to I mean, based upon zoning and city requirements for each their lot, then they need to study that whether this building can be a commercial or residential or how much total area of the floor and height can be. They have to study it, right? So all the parameters. And then during the design phase, from the schematic design, the design teams usually come up with idea and propose their building shape and overall uh, that area and down the road. So schematic design, you could see there's something more outline of the building shape and based upon their programs. But you see that through the design development, construction documentation, you see that the design and detail is continuously developed, and drawing is construction documentation should be ready in the construction documentation phase. And bidding is about most like estimation, most based upon drawing and specifications, and once client they select the design GC, then the construction gets started after maybe building permit and approval, right? So I mean, I'm not gonna touch on this too much. Actually, detail is I briefly talk. The pre-design phase is planning, zoning, master planning, site analysis, code zoning review, something like the environmental impact. I mean, all the phases. There are a lot of the studies has to be done. And sometimes concept design is architect even touch on some in general idea of the building or master planning and building shape and overall. And schematic designs, yes, as I said, that all architect and structural engineer and MEP engineer got involved and provide their own the input so that overall design is proceed together along. Okay. The one thing, since we are working on a tall building structure, so one thing that we need to keep in mind is the floor to floor height settings, because the market requires certain the ceiling height, clear ceiling height requirements, because a client usually they set their goal, their commercial office building is class A, class B, class D, C. I mean, it's all related with your rent leasing price, right? So higher ceiling means this is actually a more premier. The office class A, the 15 feet, 14.6 is typical class A office, floor to floor height 14.6. In our design practice, maybe we can use 15 round up, but 14.6 in class A worldwide, and when you can name it, that the class A office and constructed recently in worldwide, they kind of follow and sudden uh, their class A building ceiling height. So in order to determine the floor to floor height, I think as a structural engineer architect design team, we with the MEP, you see that the building floor framing ceiling sandwich studies are usually carry on because of the building span lengths require certain depths of the beam and girder, right? Typically, office building is made out of steel, and so what you see now, ceiling sandwich studies is obviously it gives us an idea of how much is building structure needed, and some space really has to be given to the main body of structure. And below the ceiling is, yes, something we need to figure out how much the ceiling height we can achieve. So sometimes the elements and depth is really play a big role here. The beam and girder depth underneath, biopropane and MEP duct and some ceiling, and the pipings there. So from top of the concrete, metal deck concrete slab to ceiling, I mean, those are all the kind of important space. And we need to really, as a design team, try to optimize this space so that we can achieve the most high ceiling our target. I mean, concrete structure is relatively simpler because typically concrete slab and beam or gutter. And typically, if residential building, high-rise building, we don't use a beam. Typically, flat plate slab we commonly use. So the residential building, we're gonna talk about it. Commercial versus residential later. The I mean, because of the uses, their ceiling height, the floor to height requirement is slightly different. The residential, commercial building, office building, typically their span is pretty large. Office space, maybe between the 40 to 45 span versus residential is maybe 20 to 25 feet. So obviously ceiling height requirement is different. We're gonna talk about it. All right. Okay, I'm gonna skip this. So based upon each phase, we are studying and developing the floor frame layout based upon the agreed column layout and beam and girder span lengths. We size those members. So we usually developing the floor framing first with some consideration of lateral system elements on in the plan and also 3D. So that is actually the biggest three primary pillars: floor framing system, lateral system, and foundation system will uh, design during the design phases. So I mean there are, I think, documentation I uploaded in Canvas. I mean, just in case, I'm gonna email you some example of concept design drawing, schematic design drawing, design development and construction documentation. You can open the PDF file so you could see each phase and their scope of works and contents, the completeness. And as I said, typically we provide, right, the contract documentations. When we call contract documentation, is include some project narrative or construction drawing, right? Based upon CD, and specification is main the documentation we provide. Yeah, typically structural drawing is covers general notes addressing the new building code, design load criteria, and also it should include enough the details information foundation um, plan, floor framing plan, section and detail, a member schedule for member size, column beam, slab, wall, and typical detail for the slab, concrete, steel, non-typical detail, and some unique structure features. So it depends on the building type and buildings, the project, obviously, but generally you should include enough information for the construction, right? And general notes, obviously, yes, building code, starting with the building code. Each state has their own jurisdiction and building code, and based upon international building codes, but each state follow the various different version of international building code and their own amendments. Yeah, we're gonna cover it next couple of classes, but we need to get familiar with design load, gravity load, and lateral load, and some, since we design foundation and we need to really coll collaborate with the geotech engineer to know about the soil bearing capacity and foundation system based upon the soil, what will be the most feasible foundation system. And so the foundation and concrete, steel, is should and some notes we usually include in our general note like this. It's a lot of wording, but this is actually give us this basic the guideline, and then we provide so that the contractor actually has to follow during the construction. And briefly, here is simple project of the foundation plan. You see the spread frame. I'm sure everybody actually take the geotech or foundation class. You see the spread frame, and some the concrete mat under the wall, something like that. Is showing the graphically location with the grid and dimension and size of the structural elements, and some sheet notes covering reference information. If this is concrete structure, yes, typical floor is typically flat plate that sometimes column, right? And a flat plate slab, we're gonna talk about it briefly in next class, but sometimes a drop panel we use, but you see that in general concrete floor framing and some steel or concrete reinforcement plan layout drawing. And I'm gonna, this is a wall, a schedule with a key plan, some wall reinforcement schedule, column schedule, which column size and reinforcement information, and typical detail of flat plate concrete, some concrete beam detail, concrete column detail. I didn't include the steel here, but I will show you some steel detail later while we are designing the office structure. And for the specifications, we typically use concrete and steel as a primary structural member, right? So we are usually provide a specification for concrete and steel for more information and product or something procedure related, that the specification is really covering more than just some information beyond that structural drawing. So, I mean, I'm briefly talk about in general. I want you to just get familiar with these procedures. I know it's project by project. There will be some variations, but either building or infrastructure, I think they are usually following similar design phase. They may using different name, but I think the what you've been heard, the schematic design, design development, construction documentation, there are three main phases you follow similar way in at the building industry and or infrastructure industry, same thing. So while we are designing the structure, obviously we are using some software, right? So one of them you just learn this today is SAP, and we're gonna also practice ETAPS later on. So I want you to actually try to give you the opportunity to learn both briefly. Yes, it take a while to learn all because this is not just software class and structural engineering class, but I want you to just aware of it. So hopefully you can find some interest from this class. So just this is something more eye-opening kind of opportunities. And okay, since 12:40, I try to wrap up that we try to have some simple exercise. Is a homework one. I mean, SAP and Rhino Grasshopper SAP, I think you can just practice every day a little bit, a few times. I think you get there. I mean, I'm gonna upload the video, but meanwhile, I want you to just kind of remind that it's all the building is cantilever, right? So as simple as this cantilever stick frame and like this homework one, we need to just practice how we can put this engineering and problem statement, how we can understand this problem statement to solve the problem. So here homework one is let's play with the cantilever deflections, right? It's about 100 feet tall. So we have a point loading 100 kips at the tip. Right, concrete is 4,000 psi concrete. Young modulars is given here. And wall cross-section is 12 inches by 120 inches. So this is cross-sections. So that wind is pushing this wall. I want you to just calculate the deflection. This is a homework one. So I'm gonna send this file to everyone. I want you to just follow along the formula, which is very simple. I mean, this is basic, and but I want everybody to just practice a hand calculation, put your all basic knowledge together. The reason why is we're gonna confirm the deflection by using the ETAPS, so that the hand calculation method versus finite element method, analytical methods. We try to make comparison and just conclude this, right? So from now on, entire your career path, I want you to aware of it. You should build the structural, the engineering knowledge with the also support of this some finite element support uh, analytical model. So this is always the two method we are carrying out during our design procedures to confirm and validate. So make sure we really don't miss anything down the road. Okay, so I'm gonna stop here. So I'm gonna email you this file to you. So homework one, just take a look at it. You can hand calculate. If you're interested, yeah, I'm gonna also email you about this ETAPS model, right? This simple model is a very simple model, but we can discuss this model, the problem, how we're gonna interpret and how to create the model to solve this problem. Something we're gonna discuss maybe next week. Even a simple example, I think worth it to discuss because there are different the method that we can use it. Okay. All right. So, okay, unfortunately, today is virtual class. I want you to just have some time to learn, practice Rhino Grasshopper SAP. I mean, the SAP, today's example is mesh shell. We're using shell, the elements, but we could do on the line. Last week, we actually practiced a little bit. So if you can practice a little bit, I think you'll get some confidence. So much better next step while we're doing the ETAPS study too for uh, the high-rise building. Okay. Anybody has a questions? Nope.
Excuse me, Professor.
Yeah.
Where would we be able to find like the video in case we need to go back
Oh,
just so we can practice
okay.
more?
Recording. Let me pause.